services, and Ben and I had talked about getting this ready, and we kind of felt there was a lot of confusion about what REST is, and through the course of actually getting this presentation ready, there's definitely a lot of confusion out on the web. So it's really good for me to kind of go through what REST is and get an understanding of it. And I think I want to start, we're going to talk about it at a high level today, and try to get down into more pragmatic things. But I think it's really important to kind of look at it from a higher level to start, and kind of the architectural level, and then go from there. There's a whole bunch of common questions that you have when you are developing a RESTful application that may come up. And so there's lots of little gotchas and things that when you actually start working on it, you're like, what do I do in this case and that case? And if we don't cover those today, like Ben said, we can have a follow-up, or you can send me an email or whatever, and try and get answers to those. So I wanted to start and just talk about the web. I don't know how many people remember life before the web, but Tim Berners-Lee in '89 wrote the initial proposal for a hypertext system. And basically in the 90s we saw exponential growth. In '93 the number of websites were doubling every 3 months. In '97 they were doubling every 6 months. And Google's first index in 1998 had 26 million pages, and by the year 2000, 4 years later, they had 1 billion pages. And in July of 2008, Google announced that there were 1 trillion unique URLs in existence on the web. So it's pretty big, and it's growing really big. It continues to grow. No one really knows exactly how big it is. The known web is crawled by standard web crawlers, but there's actually a thing called the deep web. And the deep web includes dynamic websites, unlinked content, private content, that kind of thing. And when basically when you factor in the deep web, some people believe that the web is actually infinite. There's been comments on that. But again, no one knows really for sure how big it is. So it's growing really fast, and it's really, really big, and it's successful. Parts of it go down. The whole thing seems to keep moving along. Sometimes, there's the odd time where multiple sites go down, but generally this thing just keeps on humming and keeps growing, and that's really interesting. And it kind of raises the question that what are the architectural features of the World Wide Web that have contributed to its success and its scalability? Why has it been so successful? What can we learn from it? This wasn't the first attempt to share data over a network. It doesn't use, or it didn't mandate any proprietary middleware or anything fancy like that. It doesn't talk about a model. So there's all kinds of things, and it allows for dangling pointers. It allows for broken links and things like that, and it's still, and it's working. So it was a kind of a different approach to things, and that's what we're going to kind of look at. So REST stands for Representational State Transfer, and the term was originally coined by Roy Fielding in 2000 when he wrote his PhD, his dissertation called Architectural Styles and the Design of Network-Based Software Architectures. So Fielding had been very involved in the design of the HTTP 1.0 and 1.1 specs, and so he was integral in that process. And when he wrote his PhD, he kind of summarized the thoughts and the constraints they put into HTTP to make it so successful. So if you check it out online, it's actually really quick to read the main REST part. It's like one page, so if you have a chance, check it out. So he talks about constraints. So a constraint is a rule that induces one or more properties in the architecture, something you want. And we're used to this, right? So we separate our UI from our business logic, right? And that can impose some, might make some operations a little more challenging, but that produces properties such as maintainability and evolvability. And fielding basically, calls a group of constraints a style. And so in his dissertation, he talks about the RESTful architectural style. So when you hear that, that's what he's talking about. What are the architectural constraints of a RESTful system? And there's 6 of them, and I'm just going to go through them here for you. All 6 constraints, technically, all 6 constraints have to be met to call your system a RESTful system, okay? In practice, they're not always met, and I'm going to get into some of those details later. One of the 6 constraints is an optional one, and I'll show you that. So the first constraint is client-server. So the web uses a client-server architecture, and the main principle here is a separation of concerns. So the properties that it produces are portability, evolvability, and scalability. So clients are concerned with data storage, and that improves the portability of the client code, right? You can point your browser at multiple websites. And likewise, servers can be replaced and developed independently, okay? Everyone hear me okay? Yeah?
No.
No?
Take a level.
Sure, let's try it. So the second constraint is stateless. And basically, each request from a client to a server will contain all of the information necessary to service the client. Okay, so each request is atomic. And there's a certain amount of metadata. There's a lot of metadata in the request. You see that in the HTTP headers. And the properties that this induces are visibility, reliability, and scalability. The trade-offs for statelessness is that you see a decrease in performance because you end up having larger messages because they have to tell the server, they have to give the server more information, and likewise the server has to send back more information to the client. So, a RESTful architecture is probably not a good fit, if you're creating a high-frequency trading system or something that has to be really, really efficient. It's not good for you, but it's good in other cases for things like scalability and whatnot, or horizontal scalability. The third constraint is called cacheable. So responses declare whether they can be cached by the client or not, how long they can be cached for, and by whom. And I'm going to talk about this as well a little bit later. But this constraint provides the client and any intermediary components an opportunity to cache and reuse server responses. It's an interesting way to cache. We don't always do it this way. I mean, sometimes, it's the idea of the server not actually performing the caching, but sending the data back and telling you whether or not you can cache it is kind of interesting. There may be cases where we've done that on projects here, like maybe you've added a marker interface to a model, for example, or an annotation to say, yes, it's cacheable. But you can see how it kind of decouples the client and the server. And it takes a certain amount of workload off of the server. So the trade-off here is reliability, because caches can sometimes be stale. So depending on what you've cached and whether things are working right, you may be looking at stale data. So that's kind of the trade-off of that constraint. So the next one is a layered system. Clients can't tell whether they're connected directly to the destination server or to an intermediary server. And the properties here are scalability and simplicity. And we do this every day in our code, right? So if you're working with Spring, for example, you'll have an interface, say some sort of business interface, and you'll have your business implementation, that'll be your root implementation, but then we'll use aspects. We'll generate other implementations of that interface that wrap the initial implementation, and they handle other concerns that are kind of aspects, like, for example, we might have a logging wrapper, or a security or a transactional layer. So they're doing the same thing in the web. When you send a request, when you send a request, it's going through any number of intermediaries that are performing other things with your request and your response. So, the trade-off here again is reduced performance because there's potentially a lot of interaction going on. So, the next constraint was code on demand. This is an optional constraint. And basically, servers can extend or customize the functionality of the client by transferring executable code. So obviously JavaScript, Java applets, Flash, and so forth. The properties here are scalability. You can defer processing to the client, and simplicity, because you're reducing, again, the coupling between the client and the server. Trade-offs are reduced visibility and security. Potentially, you could be downloading malicious code or whatever. And this is the last constraint. The sixth constraint is the uniform interface. This is the central feature. This is the central constraint that distinguishes REST from other architectural styles. So I saved this one kind of for last, and this is where we're gonna kind of drill into this one a lot today. The uniform interface, basically, the properties are evolvability, simplicity, and visibility. The trade-off here is reduced efficiency. We're going to talk a lot about this. So there's actually 4 kind of sub-constraints on the uniform interface constraint, and they're really the key concepts of REST that you'll hear a lot when people are talking about it. So the first one is identification of resources. So resources are identified via URIs or URLs, which are basically indicating the protocol. Resources are never manipulated directly. They're manipulated via a representation. You can have any number of representations of that resource. Okay. And there's the third sub-constraint is self-descriptive messages. All of the messages that we're sending have metadata that basically helps describe the meaning of the message. So in this case, the metadata here is media type in this example, saying it's application JSON, and the client or the server, depending who's receiving or sending the message, will know how to parse the body of the content of the message. Okay? And the last constraint is hypermedia as the engine of application state. I'm going to talk more about that later. Okay? That has to do with the contents of the resource. I'm going to just leave that for now. So the goals and benefits of a RESTful system are scalability of component interactions, generality of interfaces, independent deployment of components, and the use of intermediary components to reduce latency and enforce security. Okay, so I mentioned earlier there's lots of misconceptions about REST. Any visit to Hacker News or Stack Overflow, and you'll see lots of conversations about it. Biggest probably misconception is that REST does not equal HTTP. They're not equivalent, and I'm going to talk about this here a little bit. Just because your service is accessible over HTTP does not mean it conforms to a RESTful style. Okay, the problem is that the principles of REST were basically used to guide the HTTP protocol, and they're embedded in it. So REST is almost always described within the context of HTTP, and I'm not going to deviate from that in this. I'm not going to try to talk about it in a different way. But there's nothing to say that you couldn't use a different protocol for your application, and it could be RESTful. Okay, so you could, in theory, you could have, you know, an FTP server that is RESTful if you follow the constraints properly. There'd probably be some challenges to do that because it wouldn't be as amenable to some of the things we talked about, but you know, you could do it. So that's really important to talk about. And again, that's a big source of confusion. So related to that, I want to talk about a thing called the Richardson maturity model. And it was a classification for HTTP-based services proposed by Leonard Richardson. He's wrote a bunch of books. I've got a Ruby book by him. Rather than just say there's REST and there's not REST, which is what you often see, people just say that's not REST and that's it. He kind of gives you a model to kind of gauge where you are and how close you are to being fully RESTful. And I think it's really useful when you're looking at services or you're actually designing services to take into account this approach and determine how far you want to go. So there's 4 levels. Level 0 is basically characterized by services that expose a single URI and a single HTTP method. Okay. This is generally referred to as HTTP tunneling because you're using your own remote interaction mechanism rather than taking advantage of the mechanisms of the web. So HTTP is purely a transport protocol here and nothing more. So you can see here there's one URI exposed, and everything's going over that. It's just a post in this example. This is from Martin Fowler's website, actually, so if you want to take a look, he talks about this in more detail. But examples of a level 0 service would be SOAP, XML remote procedure calls, and Spring remoting would be a good one as well. So most of us have probably worked on a system that was level 0. It's not really meant to denigrate those choices either. You know, no one really likes SOAP that I know, but you know, Spring remoting is very useful. It's very fast to develop with, and if you're only going to be accessing a server from a Java client, then it might be a really good choice for you. So it's not saying that there's anything inherently wrong with these, but they're not utilizing the web and they're not RESTful. They're not taking advantage of some of the things on the web. Is basically the point. Okay, so the second level is called resources, and what's happening here is that rather than tunneling all of your HTTP requests through a single URI, we're starting to identify specific resources on a service. So in Fowler's example, he uses an example where someone's trying to book an appointment with a doctor. And so you've got two resources here. You've got doctors, and this is Dr. Jones. And then you've got appointment slots, and this is one of the slots that's available here. At this point, we've got multiple resources, but operation names or parameters are typically expressed in the URI itself. So you're still using one verb. Basically, everything's a post. And if you want to book an appointment, you might tap onto the URI what the operation name is and maybe extra parameters and that kind of thing. And there can be some trickiness here. One of the things I was reading, and most people say that they're usually using gets on this, and that can actually be kind of dangerous because a crawler could potentially see a get request and invoke it, and if it's actually an operation that alters state on the server, can have an adverse impact. So if you are doing this kind of approach, use a post. Okay, so level 2, we start to see verbs. So we've got multiple resources, and now we're seeing those resources expose different verbs, different operations. So, in this case, I want to find out the available slots for the doctor when they have free time. So I do a get request, and then I want to create an appointment, and I do a post request. So you can see it's starting to use more of the mechanisms of the web. In addition, you'll typically see actual use of HTTP response codes to indicate to the client what's going on. So if a new appointment's been created, you'll get a 201 response. You might get a 409 conflict if there's been if you've had stale data or something like that, trying to write it to the server. And this is the level 3. This is, so I didn't even know how to pronounce this until a couple of days ago. This is Hadios. It's like Cheerios, basically. This is the hypertext of the engine of application state. When you get to this level, typically you get to write condescending comments on Hacker News. So it's something to strive for. Basically, this is kind of the final step. This is the glory of REST, basically. This is what truly will make your system a RESTful system. Everything we talked about before is going on, but now you've got hypermedia linking up your resources, and that's actually driving the client. It's driving the state of the client. So, so in this case, when the client does a get to find the open slots, it's actually being told in the resource how to book the slot, okay? And so the initial response here of the open slot list contains information to tell you how to go further and is driving the client. And this decouples the client and the server, okay? So there's no out-of-band, there's less out-of-band information here. As a developer, you can explore the API this way. So you can start off, and it's almost the idea is it's almost self-documented. You can hit the root URI, and then find out where you can go from there and drive things. And in theory, you can change the URIs on the server and not break the client. Okay, so we see this every day in our browsers. So this is not kind of a new idea. If I'm on the New York Times and I have a link to the business page and that page breaks, or my link is broken, it's stale, I know I can start at the root URI, find the link, and progress again and find the new URI to the business page if I wanted to do that. So it's kind of along those ideas. I've got another example here. This was just here recently. A level 2 HTTP response. This is for a fictitious bank, and this is the account. And here would be a headers response where I'm including links to do other operations on the account. Okay. The links that I'm showing here, these are derived from the Atom protocol. And this is the relationship. So this is kind of the semantic information about what this does. And then this is the actual URI, and that's how you execute it. Okay.
Just can I ask a question?
Yeah.
So at the end of the rel versus slash payment, is that always going to be the entity that it's representing?
You're talking about?
Yeah, so for
this
payment URL, can you always expect to see payment or special offer as at the end of the URL?
I would hope so. So I haven't had time to kind of drill into that as much. Yeah, Basically, I think you would have to have really a stable source of like, these are the relationships that we've defined. If not, this is one of the questions I'm gonna get into, is like, I don't know how we would deal with that type of change on the client. There's clear understanding sort of what this approach does for you, but there aren't a lot of utilities or approaches defined that would say, here's the right way to do this. And to be honest, I don't know the best thing for this. Like, what would happen if I changed that URL down the road? How would people deal with it? I assume it would break clients, but there may be some way to possibly, when you're booting up your client, go and find the location of the relationships and then parse them in, and you'd have keys and then go from there. So there's probably ways to do that. So there's huge debate right now on the internet over this topic. As I said, there's often comments on Hacker News and whatnot saying, you know, what you did is useless because you didn't do HATOS. I think, you know, how big of a deal it is. Level 2 is a pretty good level, and how big of a deal it is to go to level 3 really depends on the application you're building. So there's lots of debate on this. Fielding wrote a post in 2008 basically condemning, he actually pointed out a very specific open source project, and he said, like, this is not a RESTful application. It's not using hypermedia. Don't call it REST. You know, I imagine he takes that kind of personally. Likewise, there's been other people in the field who have said this isn't that big of a deal, and it's not going to do the wonders that people are saying it is. It's nice to have if you can do it, but it's getting blown out of proportion. What I've kind of come across reading all of these comments is basically you need to weigh the benefits of HATOS and whether against the other requirements of your project. Okay, so you need to, you really need to weigh, like, implementing this is going to have a cost on how you generate your representations of your resources, and it's going to be a cost on your client because your client's going to have to drive state to really make use of this. And there's a lot of things that impact whether that cost is worth it. Is your service exposed outside of a specific organization, for example? Does it span multiple organizations? If it doesn't, you might not really get much benefit out of going to the trouble to include this. On the other hand, you might be in a really big organization that has a lot of different departments, and they're almost like, little fiefdoms, and it actually might really make a lot of sense to do this because maybe they're on totally different development timelines and whatnot. So I think right now I would just say, be aware of this, and it's kind of something I kind of want to drill in on and learn more. And yeah, there's a quote here from Fielding. It was actually in his post, and after a lot of conversation, he made this point that REST is intended for long-lived network-based applications that span multiple organizations, and that makes sense when his concern. He's talking about the web itself, okay, not a smaller application that runs inside some organization. And basically saying, if you don't think you don't see a need for the constraints, don't use them. There's nothing wrong with that. There's nothing inherently bad about what you've done. Just don't follow the REST API. That's basically it. In practice, people still do. If you go onto Amazon S3, their API would be level 2, not level 3, but it's called the REST API. Same with Twitter and Facebook. A lot of people are not doing this right now. So there are probably some really good examples. I think Twilio does use HATOS, but right now I couldn't find a lot of really big companies that are doing this. I don't even believe Google is doing this right now. So is that good? So I'm gonna talk, get a little more down now and talk a little more pragmatically about the uniform interface constraint. So we talked about verbs. So object orientation uses nouns, right? And we have a rich set of behaviors on our objects usually. REST uses nouns with a very restricted set of behaviors, okay? Whether you're writing a RESTful client or a server, you really need to understand the semantics of the verbs in HTTP. And I'm going to cover just 4 of them, because these are kind of the 4 that we typically use in our applications, get, put, post, and delete. And there's two aspects to any HTTP verb, whether it's safe, whether the operation is safe, and whether the method is idempotent. So safe basically means that any invocation of the method should not have the significance of taking an action other than retrieval, okay? So when you're using a GET request, and it's the only safe method, you're retrieving data. Obviously, you might be impacting something on the server. You might be impacting logging or the use of memory or whatever it takes to retrieve the data, but that's out of your control. You, as the client, are making a read request, and that's it. None of these other operations are safe. So obviously, when you do a put or a post or a delete, you know you're altering state on the server, and you have to be aware of that, and there's consequences to that. The other item here is idempotency, and this is basically saying, side effects of multiple requests are the same as the side effect for a single request. So you should be able to repeat the operation multiple times, repeat the method invocation multiple times, and get the same result. So for example, a good one is delete. If I delete an account on my fictitious bank, I can actually request the same operation multiple times. The server, if it's idempotent, should not give me a problem, right? I should say, okay, I deleted account 1234, and if I submit the request a second time, it should give me the same response each time. Yeah.
Just on that idempotency thing, how does time play in that factor on a get on getting account balance or whatever?
So how does what?
How does the time play? It changes state on the other side. So it's idempotent as long as the state hasn't changed, or does that apply equally to sort of put or as well as an get? If I deleted, other stuff has happened, but I delete again, it's that kind of stuff.
So yeah, the idempotency in terms of the get, like you could do a request on an item and then 5 minutes later it could be gone. It's not guaranteeing that the item doesn't change. That every resource has any resource can be temporal, right? So it can change over time. That's not a problem. So in that sense, it doesn't violate idempotency. Okay.
It only makes sense, assuming everything else remains equal, right?
I just have to look at the definition of what idempotent is.
Yeah.
Fine, I was just curious.
I think it's more about your action.
It's about the side effects.
Yeah, no,
So you could in theory have a client in a loop.
I
And you could
understand.
run it for 3 days and request the item, and eventually you might get on the server. There's no side effects. So, where was I? Okay, so and put is also idempotent, and then post is the one that's not idempotent. Okay, and put versus post. There's a lot of confusion over when to use a put and when to use a post. Okay. Again, you need to consider the semantics of these two methods and how you want to implement the operation inside your service to determine what the right choice is. There's what happens a lot of the times is people automatically map these operations and they assume that a put is for updates and a post is for creates, and that's the way it is, and it's actually wrong. Puts can be used for creating items. It says so in the spec. And posts are, post, while it's typically used for create, can also be used for updates. You need to consider, in this case, whether your operation should be idempotent or not. So I have a trivial example. So in our bank account service, if I wanted to add deposit functionality to my bank, which verb would I use? Which verb would you think is appropriate? Throw it out. Does anyone have that?
In the example you have there, post is appropriate,
Yeah,
but put could be appropriate if you had a transaction number on it.
exactly. Yes. So most times you would look at a bank account. You would say, when I do a deposit, I'm altering state. I'm increasing the balance of the account. So that's a post because that's not idempotent, right? But like BC said, if you have a scenario where you're sending the deposit and the deposit's uniquely identified, then you can send it to me 100 times, and I know not to necessarily increase the bank account every time if I've seen it. So the way I like to think about this is, if you're the client and you're requesting an operation, a write operation on the server, what should you do if you don't get the response back? How do you know whether your operation was successful or not? Okay. Basically, if you think the user should be able to re-request the operation, if it's safe for them to re-request the operation a second time, then you want to go with put. And that's a really good way to go with things, because it allows clients to handle failures really easily. They can just resubmit the operation a second time. And otherwise, if you're taking control of the identification of the resources, it's a post. So an example of this would be from eHealth. When we were working on eHealth systems for shoppers, and we had to integrate with these provincial eHealth systems, pharmacies would send up new prescriptions to be recorded on the user's eHealth record, okay? Their central eHealth record. So, if you're just going with the kind of automatic mapping, you would say that's a post. If I was implementing that eHealth system as a RESTful service, I'm creating something, it's a post. But the reality is that the pharmacy has a unique ID on that prescription. They've got their OID, which is their namespace, and they've assigned an ID to that prescription, and it's unique. And it actually it's probably better in that case to implement the operation as a put. And I believe they do implement it as an idempotent operation. They're not using REST, but they make it idempotent, so that if you send up the prescription and for some reason you didn't get the response back, it's safe to send it a second time. You can send it 20 times. They'll just give you the same response back. Okay? So yeah, in this case, if you wanted to model it as a put for the deposit, you need some other information, such as like a globally unique ID or something that would identify clearly that, so that the server can handle it appropriately. So, okay, so is that good? Did anyone have anything on that? Okay. So the next thing I was going to talk about is transactions. So the REST style doesn't really have anything to say about data stores or transactions, but the stateless constraint requires that session state be stored on the client. So requests can't take advantage of stored context on the server. This basically means that your transactional boundaries, when you're designing if you have transactions in your service, they shouldn't span more than one request. And this might be obvious, but so if you require transactions, you need to make sure you design your service API to accommodate them. And I just have a simple example here where, if you were doing a transfer of money between two accounts, a very naive way would be to say, okay, I'm going to do one operation to post a debit to one account and do a second operation to post a credit. it's not a very good way to design the API, and the way you work around it is you kind of model things a bit differently. And in this case, you post a transfer to the journal. This is just one way that you could do it. And the body of that transfer has all of the data necessary to complete it, and it can be done in one transaction. So that's one of the challenges that you run into with this uniform interface. Okay, you only have so many operations, and really, I guess the art, in it is designing the API and thinking about the nouns, which is something we're kind of familiar with, I think, with OO and what we do every day. So it's a bit of a modeling exercise. Just a really brief slide on this. That it's just carrying on with the stateless constraint, is that it does enable horizontal scalability. So if your service is truly stateful and your server is not is playing by these rules and obeying this constraint, then you can theoretically expand and have multiple implementations of a service. And this is one of the things that goes on in the web, that you can just start popping up multiple instances of your service, and it's very easy to scale. The catch here is that you need to make sure your database or your data store will also be able to keep up. And that's kind of why you're seeing all these NoSQL solutions to try and match what's going on in the servers. So the next thing I was going to talk about is caching. So HTTP responses, as we mentioned, they can indicate if and how long they can be cached. There's some benefits here. Reduced bandwidth, reduces latency, reduces load on servers, and it can actually hide network failures. If you're writing a RESTful service, you can get some things for free that we typically would do on our servers. So, typically you might write some code to cache something out of the database that's static, is not going to change. You can still do that, but you can actually take advantage, if you're writing a RESTful service, of these the cacheable properties in HTTP, and basically get it for free. So you can start to drop in proxies in the network that will do caching for you, like Squid and whatnot. And you can also expect the browser to cache data for you as well. And not just the browser, but also some of the programming, some of the RESTful kind of programming toolkits that you can use as clients will also do that. I'll talk about those in a little bit. So there's a few cacheable headers here. One is expires, and it specifies an absolute expiry time. And the other is cache control, which contains kind of a list of directives indicating whether the response is cacheable, by whom. So private is saying it should only be cached on the browser, not on a proxy server or a reverse proxy, and for how long. So this would be like 1 day. And the second one, I'm calling them conditional cache headers. In addition to what we saw earlier, you can send two different types of headers that can be used for conditional requests. So the first one is the e-tag. This is sent on a response. It's a content-based header, and it's any unique string, and it identifies the resource that's being sent back in the response. And basically, so if you make a request for a bank account and you have an e-tag header in the reply, in a subsequent request, you can send that e-tag header in the if none match, and the server can say whether or not the data is stale. And if it's not stale, the server will send back a 304 not modified response. I'll show you that in a second. This is the same idea here: last modified, if modified, since. These are time-based headers that basically do the exact same thing that you tag and if none match do. So here's the idea. I was just kind of getting ahead of myself there. So client browser makes a request and says, here's the e-tag you gave me, I need the person again, give it to me. And the server can say, you've got the latest person, sends back a 304 not modified, and everything's good. Or it can actually send back a 200 with the latest updated person and the new e-tag for that person. So the idea here is you're still making the request, but you're cutting down on bandwidth on the network, okay? I'll leave for time. And last thing, just on caching here, responses, HTTPS responses can't be cached, okay, because they're encrypted. There are some ways to work around that. I'm not an expert on them. I read some stuff about you can set up a proxy in the middle that does all the key signing and whatnot and can actually do caching for you. I can't really comment on that. Another approach that people mention is if you're okay with your headers being exposed, you could just cache the client. You could use HTTP and cache the body of your request. Sorry, encrypt the body of your request, and that's kind of a workaround if you want to do it. But I can't really talk too much about how useful those approaches are. So.
It's only that they can't be cached by intermediate proxies. They can be cached by the browsers, right?
Right. Yes. Yeah, that's right. Okay, so I thought I'd mention this. It's kind of probably an obvious thing to most people, but one of the things that you'll see when you're looking at examples of implementing a RESTful service, whether it's JAX-RS or using Spring REST, is that every example kind of says, great, here's how you map your service method to your URL, and they go right into the business logic, and everything's good. And that's a bad way to go about developing. Okay, so we know here that we use layers, and my point here is just really keep in mind if you're working for the first time on a RESTful service, you want to have a separate layer that handles the RESTful concerns from all the other concerns. Okay, so on the business logic tier, when a request comes in, you have a package dedicated to RESTful that has your RESTful services, and then you have your RESTful annotations. You can handle mapping exceptions in the lower layer to the appropriate HTTP error code and whatnot. This will obviously make your code more testable. It separates the concerns and it'll make it easier for people to read. It'll allow you to expose your business service layer possibly to other means of communication, whether it's JMS or RMI or whatever you happen to be using. So we made this mistake in about the first month on the standard web project, and we kind of had to clean it up because we were just kind of looking at the available books out there. Just, save yourself some time and make sure you separate it. It goes the same goes for the client. So in this case, I'm showing a web UI tier where you have maybe Wicket and some service layers, and then how do those service layers actually connect to the backend service, put them through your RESTful client there. So just kind of a heads up. It's pretty straightforward. So clients, how are we doing? Do you want me to? Really quick.
It's a good point to stop and just have the conversation and questions, or what do you do? Is there about 5, 7 minutes left?
Does anyone have questions or?
Comments?
No, go ahead.
Is there a recommendation for representing dates? Dates and times?
No, I don't think. You mean in your resources, like in your representations? There's nothing on the web. I think it comes down to, in our experience, it came down to the tool you're using to marshal things. So we were using Jackson to marshal our objects as JSON, and it chose to use just longs. It would just represent them as a long. And we actually, I think there were cases where that wasn't really good enough. We needed to get other information like the time zone and whatnot. So yeah, that's a good point, but it somewhat falls outside of the scope of REST, I think, a little bit, but it is an issue that, yeah, you need to kind of be aware of.
Do you have any opinions about the pattern? I've seen it a few times where your URL space plays double duty between a RESTful interface and a web interface. So if I have a browser sending up an accept header that says, I accept HTML, you get HTML back, but you can invoke the exact same URL with an accept header that says, I'm looking for JSON, and suddenly it's behaving like a RESTful interface. Is that a good thing, a bad thing, a weird thing?
So, okay, yeah, so BC is saying, actually, I'm not sure if I have an example up of that, but yeah, you can hit the person URL and you can actually indicate what representation of the resource you would prefer. That's what you're saying? So that's actually one of the key things in REST. You can include that metadata. It's called the content type header. And you can say, hey, I'm looking at person, I want to see person in HTML, or I want to see it in XML, or see it in JSON. And the server doesn't necessarily have to implement them, and no server is going to implement every media type, but it's kind of the preferred way to communicate. The other way that people do it is to use a suffix on their URL and say I want .html or .xml. I prefer the other approach because to me the URLs are really talking about the resource that you're trying to address, right? And if you're putting the suffix on the URL and saying I want .xml or .json, it's kind of trivial, but in a way you're saying they're different resources, and in actuality they're not. Do you know what I mean? Like I'm still talking about the same person, but I'm talking about the type of representation, and to me it's better to put it in the header. That said, traditionally people did that because it made it easier to use a browser to test their service. So people would often just pop the MIME type basically in the URL, and it made it easier to test. And there's actually examples. I kind of looked into that, and Fielding actually doesn't care either way. Like, it's up to you, because you can, in theory, you can have multiple URIs pointing to the same resource. So I don't know if there's like my preference is to actually use the content type, but I don't think there's any, I don't think you're violating the actual constraint to do that, because you are free to have as many URIs. URIs don't have to be unique. You can have different URIs pointing at the same resource if you want. That's kind of okay. But on that, I'd like to just show you this. It's kind of related. I don't know if it's gonna. So there's a really good, if you're trying to play with your service and try some things out, you don't always want to drop down into code to do it. Traditionally, people would just, in older browsers, we just had to use the, pop in the URL, and you didn't really have any control over the headers that were being sent. So you might have gone to curl or some other command line client to do that. There are lots of plugins now to help you develop your REST service, and this is one of them. I've been using this. It's called Postman. It's really good. It's HTML5, so it stores all of your data locally in your browser, and you can modify the headers in your request and everything else, and it does. It'll print your JSON, and you can analyze the headers in your response and everything else. So it's pretty convenient, and if you're not using it and you're working on a service, you should try it. It's pretty good for driving things. Yeah.
Is that assuming your service is deployed somewhere, or could your service be on local hosted? Can you still
Oh
use
yeah,
it?
yeah. It's just basically a plugin in the browser, so it can be anywhere. Yeah. You can also add authentication headers and whatnot to your request. It's pretty useful. So.
Any comments on describing your REST APIs?
Yeah.
Or is that another talk?
Yeah, no, so I didn't, so I did read this about 5 or 6 months ago. There is a language out there, I think it's called Waddle, and there is a way to specify your API. No, sorry, it's not. Is that the web services? Is Waddle web services? No, it's.
Wisdom.
Yeah, that's Wisdom.
But there's
It's a
nothing to
Waddle,
it.
yeah. And someone came up with a way to say, here's my API. It kind of gets knocked, in the book I read a book called REST in Practice, they kind of knock it because they say, again, that's that's out of band information, that's not true REST. You should be driving it through the hypermedia.
Oh.
Yeah, but, that's all good. In reality, if you go to Twitter or you go to Facebook or Amazon, they have documentation up there, and because you have to get started and you want to be able to figure out the ins and outs of this thing. So I don't see it personally as a bad idea to use that. I can't say how good Waddle is for generating it.
But if you document through hypermedia, you have to document your payload.
Yeah,
Your payload contains your hypermedia, so
and
you're
it won't do
documenting,
that.
and it won't do that,
Yeah,
so
you'd have to be trying it
you
out in
kinda
some
it
sandbox or
doesn't-
something. Yeah.
solve the problem.
Yeah.
Hypermedia doesn't solve the problem.
Yeah, and I think I did also look into we used JAX-RS on our last project, and I was looking into there are some efforts right now to be able to generate an API, and that there may actually be some utilities that can go through your classes, find the annotations, the JAX-RS annotations, and generate an API for you. So that would be, if there isn't out there, that would be the way you'd want to do it, right? Is either your Spring REST annotations, that's usually the way in Java people are doing it, or your JAX-RS annotations, you want to kind of have some utility that can go through your classes and generate appropriate documents from those.
We
But they won't be sufficient.
basically, the way we did it, and you already know this, but the way we did it is we annotated with JAX-B, and there's a plugin that turns your JAX-Bs into JSONs, and therefore we described our APIs, including all the payload, with an XML schema, but you could call it with JSON.
Yeah.
So the description of your API is done through an XML schema, and your access can either be XML or JSON
Yeah.
from that point, and that seemed to work well from
Yeah.
describing it.
Yeah.
Describing it for humans or for code?
Usage. Well, a human has to write code, right?
But yeah, but code can
So
be
the human
generated.
has to understand what the payload is before they can write the code. Therefore, you have
Yeah.
to communicate that
It's like
first name is actually first name
Yeah.
and stuff, right?
these are the
And
practical
it's-
gaps that, and I haven't really gotten into them too much today, but that it's a good point that, hypermedia is great, but if I have to sit there and explore the entire API, which could be changing at any time, that's not always the most useful thing. And it's nice to deliver a document to your users to say, here are the common operations. And again, like all the big sites do that, Twitter, Facebook, Amazon, they all kind of have they have to, right? They publish their API. The other thing about the hypermedia thing that I was reading, and again, back to that debate, is the idea of changing URIs is one of the reasons people are pushing it. Like, you're decoupled, you can change the URIs on your service, and yet that kind of violates, or it runs up against the cool URI recommendation from the World Wide Web, which so way back in the day they said, look, make pretty URLs and make them stable and don't change them over time. You shouldn't even, the documentation says you shouldn't change your URLs, you shouldn't have to change them. That might be going a bit far, like eventually there might be a reason why you have to change it, but you should be really thinking hard about what the right URLs are, what is natural for people to understand. And again, that's just a modeling thing, right? So that example I gave of having a journal and a transfer, submitting a transfer, that's a good way to do things.